A nucleus at rest undergoes a decay emitting an alpha particle of de Broglie wavelength 5.76 into 10 to the power minus 15 meter. If the mass of the daughter nucleus is 223.610 AMU and that of the alpha particle is 4.002 AMU, determine the total kinetic energy in the final state. Hence, obtain the mass of the parent nucleus in AMU. So over here, the question is saying that a nucleus at rest is undergoing alpha decay. So I can begin the problem by writing the chemical reaction that is involved, the nuclear reaction that is involved. So I'm saying that a nucleus X with atomic number and mass number Z and A undergo alpha decay. So I can say that the Y that will be obtained will be having Z minus 2 and A minus 4 as atomic number and mass number. So over here the question is saying that mass of Y is given to us as 223.61 U and that of alpha particle is given to us as 4.002 U. Now we are dealing with the next aspect. It is saying that when it is decaying an alpha particle, a de Broglie wavelength of 5.76 into 10 to the power minus 15 meter is produced. So from the formula of Broglie wavelength, I am writing lambda is equal to h by p, where I am writing p as mv, and from here we can write it as m square v square can be written as h square by lambda square, which we call as p square. So the value of kinetic energy which we are looking for is equal to p square by 2n, and hence if we put the value of p square as h square by lambda square, we get kinetic energy as h square upon 2m lambda square. So now we are applying the equation. This is going to be our working formulation for obtaining the value of kinetic energy for alpha particle and the nucleus Y. So over here we can say that the kinetic energy for alpha particle can be calculated as h square, that is 6.6 into 10 to the power minus 34 square upon twice mass of alpha particle, that is 4.002 AMU. So convert it into kg. So 1.67 into 10 to the power minus 27 kg. And then there is lambda square. So for lambda square, we are putting it over here as 5.76 into 10 to the power minus 15 whole square. So this is the number we divide with to obtain the value of kinetic energy for alpha particle. On solving, we obtain this value equal to 0.982 into 10 to the power minus 12. Now we will do the similar set of calculation and obtain the value for kinetic energy for Y. So I am not showing you that long calculation. So you can do the calculation and obtain the kinetic energy for Y is 0.0178 into 10 to the power minus 12. So from here I can say that the total energy, the value of total energy can be written as kinetic energy of alpha particle plus kinetic energy for Y. So if I add them, we will obtain a value equal to 10 to the power minus 12. So now we are calculating the equivalent mass. So we are calculating the equivalent mass. So if we go for the calculation of equivalent mass, I can write that delta M is equal to E by C square. So equivalent mass can be calculated as 10 to the power minus 12 upon 3 into 10 to the power 8 whole square, and the value will be obtained in kg. And we can convert this kg in AMU by using this simple expression that 1.6 into 10 to the power minus 27 kg is equal to 1 AMU. So we can do the necessary conversion and convert the kg into AMU. So over here we obtain the value equal to 0.00665 U. So this is the value in AMU that we obtain. Now we can say that the mass of the parent nucleus X can be obtained as, so the mass of parent nucleus X will be mass of Y plus mass of alpha particle plus the mass defect or the mass that is lost or liberated in the form of energy. So that was the idea why we calculated the value of energy and then we calculated mass equivalent so that we can calculate the value of mass of X. So over here, if we put the values, we can write it as 223.61 plus 4.002 plus 0.00665 and the value will be obtained in EMU. So we get a value of 227.62U. So this is going to be the answer for this particular problem.